in the last video, back again, hey, we're going to nail this down, right? We're going to nail this down. Okay, in the last video, basically we showed how a router takes the binary, right, and ANDs them together to find the network. So it took the IP address 200.168.6.101 and ANDed it with the net mask 255.255.255.0, and this ANDing process, if you don't really understand the logic behind the ANDing process, which is like A and B basically both need to be true for C also to be true. So A and B results in C being true. You could just call it like multiplication. 1 times 1 equals 1, 0 times 1 equals 0, 1 times 1 equals 1. If you do this and basically AND or multiply the binary together, you will get the network. And in this case, the network for this IP address, the network address is 200.168.6.0. That's the network address. Nobody can be that address in the network. It's the first address in the network. .0 is the first, basically, host in the network, which becomes the network address. The last would be .255, and nobody can be that because that's the broadcast address. So the usable hosts in this network would be 1 to 254, right? And you can see here we have host 101, so that's a good host address in this situation. Now, what if we want to break this network up into more networks? What if we want to subnet it? So now we're going to start getting into subnetting. All right. Took us a while, but we're going to get into subnetting. All right. So we want to divide this 6.0 network into more than one subnet. Okay. To do that, what we do is, got the IP address doesn't change. We change the subnet mask. And in this case, what we're going to do is we're going to change the subnet mask to a 255.255.255.224 subnet mask. Or, in this case, it would now be 27. Okay, /27. Now, here's the rub. What does that mean? What is he doing? Why is it 224? You know, this craziness. Well, you only understand it if you understand it in the binary. That's the only way to understand it. So, what it means is, instead of having 24 ones in the subnet mask, 8 ones here, 8 ones here, 8 ones here, right? We're going to add 3 more ones to the subnet mask. We're going to borrow bits from the host portion. So we're going to borrow 1, 2, 3 bits and convert them to ones, right? 1, 2, 3, 4, 5, 6, 7, 8. So we've now added 3 more ones, and these 3 ones that we've added here, these are your subnet bits. These are your net bits, your net mask bits, and then these borrowed bits here that we've converted from zeros to ones are subnet bits. Now, if you count all the ones going from left to right, we now have /27 or 27 ones, right? And that adds up to 224 because in an 8-bit number system, people, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7th power, right? In an 8-bit number system, each one of these bits has a place value, and the place values are 128, 64, 32, 16, 8, 4, 2, 1. So, if you take 128-bit, this is the 128-bit here, this is the 64-bit here, this is the 32-bit here. If you add these up together, add them up, you'll get the 224 number. These will add up to 224, and that's why we have a 255.255.224. Okay. So now that we've done that, it changes the network completely, because before we had 8 bits for hosts. We had 254 hosts possible last time. Now we have less zeros, so we have less hosts possible. So we only have 5 bits for hosts, 5 zeros, which is 2 to the 5th power, or 32 hosts possible in this network. And what does that mean? That means that this last one that we borrowed is the magic number. This last one has a value. It's in the 12864 32's place. Remember I said each one of these bits has a value, a place value. 128, 64, 32. 1, 2, 3. It is in the 32 place, and that is its value. So its magic number, the magic number in this situation is 32. And what does that tell us? It tells us where the networks are, and that is so valuable in the Cisco CCNA. If the magic number, this bit right here, is 32, then we know the networks, where the networks start. The networks will start at 0, 32, 64, 96, 128, 160, 192, 224, and those will be the networks. So now we've taken and we've divided the network from one network of the 200.168.6 network into the 200.168.6.0 network, the 200.168.6.32 network, 64 network, 96 network, 128 network, 160 network, 192 network, and 224 network. So we have created 1, 2, 3, 4, 5, 6, 7, 8 networks. 8 networks by using a /27 subnet mask, or a 255.255.224. Notice how each network number goes up by 32. The magic number tells us that number is 32. So you're like, this is crazy. Why does this help me in the Cisco CCNA? Well, because in the Cisco CCNA, they're going to ask you a question. They're going to say, what network is 101 in? What network does 101 belong in? Well, in this case, 96 to 127. The next network is 128. This network's 96. It belongs in the .96 network. So what network is 101 in? It's in the 200.168.6.96 network. How do we know that? Because 101 is in between 96 and 127, and it falls within that range, so it's in the 96 network. The broadcast address in that network will be 127. That would be the broadcast address. This is the network address, 96. So in a /27, that's the result. And that is essentially the magic number at work. In the next video, we're going to put it to use and we're going to solve problems according to that.